Fish, the vibrant creatures that rule the world beneath the waves. But interestingly, across many cultures, they are often seen as a classic example of poor memory. In English-speaking countries, you've probably heard the phrase, the memory of a goldfish, used to describe someone who's forgetful. This idea comes from the long-standing belief that a fish's memory lasts only about 3 seconds. But is that actually true? Does a fish's memory really last only 3 seconds? As it turns out, scientists had the same question, and they decided to put it to the test. So what did they find? Today at Dr. SciVera Studio, we're diving into the science to debunk the myth of fish memory. Before we get started, make sure to hit that subscribe button so you don't miss any upcoming videos. Alright, let's dive in. Alright, let me start with a quick question for you. Even without checking a clock, most of us can usually tell roughly what time it is, almost like we have an internal clock. So then, do fish have a similar ability to perceive time? It might sound like a strange question, but there were researchers who took this idea very seriously. Back in 1994, Dr. Phil G. from the Department of Psychology at the University of Plymouth in the UK, along with his colleagues, set out to test this. They conducted an experiment to see whether goldfish can perceive time, and published their findings in a scientific paper. First, the researchers trained the goldfish using a simple setup. Whenever the fish pressed a lever, it would be rewarded with food, and the initial results were quite interesting. Over a 24-hour period, the goldfish pressed the lever at fairly regular intervals, roughly every 15 minutes, usually about 3 to 5 times. Once the fish got the hang of using the lever, the researchers decided to turn up the difficulty. Instead of rewarding every press, they limited food delivery to a specific 1-hour window each day. For one group, food was available only between 2 p.m. and 3 p.m. For another group, it was available only between 2 a.m. and 3 a.m. After some time under these new conditions, something remarkable began to happen. The goldfish gradually started to recognize when food would be available. If we look at the data, a clear pattern emerges. During the 4 to 6 hours leading up to feeding time, the fish almost never pressed the lever. But as the scheduled feeding time approached, the frequency of their lever pressing started to ramp up. In the final 15 minutes, just before food was delivered, their activity reached its peak. Then, within about an hour after feeding ended, they stopped pressing the lever altogether. In other words, these goldfish didn't just learn how to get food, they learned when it would be available. This led the researchers to a key question. How exactly were the goldfish keeping track of time? In the first setup, the fish were exposed to natural changes in light and dark throughout the day. So to test whether those external cues were necessary, the researchers introduced a new group and kept the lights on for 24 hours while running the same experiment. And the results were striking. Even without changes in light, the goldfish still pressed the lever at the expected feeding time. This suggests that goldfish can distinguish time using internal biological rhythms, rather than relying only on external cues like light. Building on this, Professor Cullen Brown from the Department of Biological Sciences at Macquarie University in Australia took things a step further. He explored learning and time perception in a wider range of fish species, and in 2015 published a paper on fish intelligence, sensory abilities, and ethics. In his work, he proposed a simple and intuitive way to test a fish's sense of time. Imagine a tank where food is provided at one end in the evening and at the opposite end in the morning. If the fish begin to gather at the right place at the right time, it suggests they've learned to associate where with when. Through this approach, Brown found that certain fish, such as posiliids and galaxiids, were able to form this time-food association in about 2 weeks. But here's the kicker. What makes this even more interesting is that the exact same kind of experiment has also been done with rats. So how long do you think it took the rats to learn the same task? It took about 19 days. That's right. In this case, the rats actually performed worse than the fish. So maybe from now on, instead of calling someone forgetful a goldfish, we should be calling them a rat. Whatever the case, the results we've seen so far suggest one thing. Fish cognition is far more sophisticated than we might expect. But this leads to another fascinating question. If fish can understand time, can they also perceive space? To explore this, another experiment was conducted in Japan in 2005. A research team at Keio University, led by Professor Shigeru Watanabe and Dr. Shinozuka, set out to investigate the spatial learning abilities of the common goldfish, Carassius auratus. Their goal was to determine whether these fish could locate a specific target where food was placed through spatial learning. The researchers divided the goldfish into 2 groups. For the first group, food was always provided at a fixed location, while for the second group, the location was changed randomly each time. The results were clear. The first group quickly learned where the food was, reaching the target faster with each trial. In contrast, the second group struggled to locate the food and consistently took more time. This provided clear evidence that goldfish are capable of spatial learning, but what's truly fascinating is how they did it. Rather than simply memorizing a sequence of movements, the goldfish relied on extra maze cues. They used information from their surroundings, such as the colors of the walls and other environmental features, to locate the food. In other words, they were processing and remembering complex spatial information. But the Keio University team didn't stop there. In 2009, they took things even further with another fascinating experiment. This time, they moved beyond time and space to ask a completely different question: music perception. For this experiment, the researchers selected two pieces of music, Bach's Toccata and Fugue and Stravinsky's The Rite of Spring. Some of you may not be familiar with these pieces, so let's take a quick listen first. What do you think? To us, they sound completely different. But here's the real question: can fish actually tell these two pieces apart? To test this, the researchers installed speakers underwater. When Bach's music was played, food was delivered at a specific location. But when Stravinsky's music was played, no reward was given. They repeated this training multiple times and observed how the goldfish responded. And the results were surprising. The goldfish responded to Bach's music, the one associated with food, with over 85% accuracy. This suggests that their behavior was not just a simple reflex. They had learned and remembered patterns in the music. And honestly, isn't that a bit surprising? Even we sometimes struggle to tell apart complex classical pieces, yet goldfish were able to distinguish between them. So then, how long can fish actually retain these kinds of memories? To find out how long fish can actually remember, researchers designed an experiment. In 2014, a research team led by Professor Trevor Hamilton at Macquarie University in Canada set out to test how long a fish's memory could actually last. They focused on the African cichlid, Labidochromis caeruleus. The setup was straightforward. The researchers trained the fish to find food in one specific spot for 3 consecutive days. Then came the real test. They removed the fish from that environment and gave them a 12-day break. After nearly 2 weeks away, the fish were returned to the original tank. Using motion tracking software, the team carefully tracked their movements. The results were clear. The fish showed a strong preference for the area where they had previously been fed. This suggests that they had not only learned the location, but also retained that spatial information for at least 12 days without reinforcement. Of course, not every fish fits this pattern. In one study, researchers tested Nile tilapia by feeding them at one end of the tank in the morning and at the opposite end in the afternoon. Even after 30 days of training, the tilapia failed to make the connection. They simply didn't learn to associate time with place, but it's unclear whether the issue was memory or something else. If you think about it, for a fish living in the wild, the ability to link food with a specific time and place isn't just a neat trick, it's survival. A fish that remembers where food is has a clear edge over one that doesn't. If it can recall a spot where food is available and predators are minimal, it can return there again and again. And when resources become scarce, those that remember where to find food are the ones most likely to survive. Considering how many species have disappeared throughout Earth's history, the fact that fish have survived this long isn't a coincidence. It reflects their ability to learn and to remember. So the idea that fish are simple or forgetful may not be true at all. Alright, so after everything we've covered today, what do you think? Has it changed the way you look at fish? Maybe they're not as simple as we once believed. And when you think about it, on those days you go fishing and come back empty-handed. Maybe it wasn't just bad luck. Maybe you were actually in a quiet battle of wits with something smarter than you might expect. So the next time you don't catch a thing, don't be too hard on yourself. Just smile and think you must have run into a particularly clever one today. That's all for today. I'll be back next time with another fascinating science story. This has been Dr. SciVera. Thanks for watching.